I'm from KIGAM. This is the under Ministry of Science, Technology, ICT. This is government organization. Under that, we actually have several, actually 22 national institutes. KARI and KALSI and KIGAM is one of geoscience and mineral resources. So we have a different expertise. So I'm not, at the moment we are planning lunar mission for lander and other things. So I'm reluctant to say, so I minimize my talk in what I've been involved in as a KIGAM employee. I'm sure everybody knows about KPLO by now. So it has launched August 5th Korean time last year. And then it took about 4 months and 3 weeks to reach the moon. And now successfully for several months, we are on the moon, and all the data collections are very successful. And originally it was for one nominal mission to be 2023, but many results are very, very good. And we proposed to extend the mission to be 2025. This will be announced by today in Korea officially. So I would like to mention about KPLO gamma ray spectrometer. Especially this spectrometer is very interesting, and then also giving out more result than we expected because of time was very interestingly, we actually designed the instrument, and then the result was really surprising. So detection of the gamma ray burst 221009A, it was a historical gamma ray burst, and that we measured. And monitoring of a solar flare is very important because right now we are reaching toward solar cycle 25. Because of these activities, lunar radiation environment, we especially can have the mapping for radiation environment mapping can be possible. And in most cases, lunar mission was focused on lunar mineral mapping and for lunar geology and resource prospecting, but we actually did one, two, three. We cannot say like accidentally, but because of time, we are doing this kind of science very heavily right now. So KGLS is located in, you can see in the center, the yellow, the circle, and the electronic box is inside. So this was made in lanthanum bromide, and then I put boron, 5% boron loaded plastic insulator. This actually works as a neutron detector, and it is the lightest instrument as a gamma ray spectrometer for planetary investigation, 6.3 kilogram, and the collection times 10. And we are able to measure X-ray, gamma ray, and neutrons. This is very interesting way that we can do lunar studies. So I will introduce the result. So this is the gamma ray burst 221009A, and the location, you can see the pink blinking. That is the location where we got where the gamma ray originated. So it is about 1 in 10,000 years. It's very rare and it's very strong. It came from far away and about around 2 billion light years, and then actually started from that because of light, right? And because we have a very narrow window. So this location is a Sagitta constellation. And we have only a narrow region, time window to measure this gamma ray burst. So I will prove how this was strong with our instrument. So actually, I was so excited about this. And you can see the trajectory, and it was the farthest distance we can go is 1.55 million kilometers, but the measurement was done at the location of 1.51 million kilometers. And by looking at the magnitude, it's about 98 times. But if the summing, it is much higher. So because of this situation, actually I made, five gamma ray channel, like X-ray regions and low energy gamma rays. And then also the total count of the lanthanum bromide, we have a low gain, high gain, and then BLPS, that's a neutron can measure. So we have actually 8 channels can be used for counting, count as a counter. So here's the data. You can see not only just like a very narrow, the counting data. This is actually spectrum. So from the 0 to 7 MeV spectrum, summing it, then you can see the bottom one is actually, this is the background. In the background, the lanthanum bromide had the intrinsic spectra, and the top one is actually the first arriving. You can see the very bright one is you can see that's top one, and then later on we have a small burst coming again. So actually that from the background level, the first gamma ray is actually 1,000 times 479 bright, mainly higher. So this is very quantified data we provide. I don't think this kind of data have done by gamma ray spectrometer before. And if we compare with this Fermi data or publication, exact time is really interestingly, we recorded this about the core time is about 6 minutes, and then you can see how we can compare with other data. And also ionosphere, and also this ESA, there's a ESA measurement was done, and they all matched well, and we are very happy that the KGRS had this kind of historical data. Another exciting moment is coming recently because the solar cycle 25 is exceeding predictions. We probably previously thought that the blue line was possible way, but now you can see it is already going toward the higher altitude, the magnitude here. So if we think about the solar, the sunspot number, 2023 about 150. So which means by 2025, it will be much, much higher. So that is probably going toward the top curve. Yeah, this is actually, I wanted to show, just feel about what is solar minimum, what is solar maximum. So it's like the 1 minute before. So KGRS KPLO will be extended, the mission will be extended until 2025 December, which means we can cover solar cycle maximum and a little bit further. So we're going to have a very interesting data coming in few years' time. So this is another exciting data. This is the NASA's the image, and then also NOAA data. You can see the red circle, coming out. That is March 13, 14, 15. So it is a coronal mass ejection coming. So what is coming out is actually, of course, gamma rays, but it is actually protons coming out. So anyways, we are checking this kind of space weathering data together with our data. And our data shows September 2022, October, February, January is a little bit lower, more likely the X-rays and gamma rays, and then very, very minor. And then March 13, 14, 15 is very high. And then May 9 also we had. So if we look at the data, I'm sure everybody knows that the solar cosmic rays consist of mostly protons. So across 90% of proton is coming, but the energy is very low. Like you can see the top curve is actually 10 MeV line, and the other one is 50, and the green one is actually 100 MeV. So we measuring protons flux by NOAA, and then the right side KGRS is measuring the top surface, top graph is actually the gamma rays, channel 1, 2, 3, 4, like X-rays and low energy gamma rays, and the bottom one is actually total count is like up to 7 MeV, 4 MeV, and then the green one is actually neutron count. Yeah, neutron count. So this is very interesting way that protons coming in, and what we see is actually this kind of secondary neutrons and the other gamma ray and X-rays. So there was the warning around March 13, 14. So that was the exciting research going on at the moment. And I could say preliminary result of KPLO-GRS. So at the moment we are making the preliminary actually map. So I'm not able to go details, but you can see Chang'o data and then KGRS. The bottom one is KGRS. So we have deep space background measurement and background measurement on the lunar surface. And you can see the low energy. We see the spectrum for low energy. So that is one difference. Sorry. Yeah. So yeah, we'll continuously produce maps based upon this. So hopefully our map can be utilized for future lunar investigations and the Artemis program. And previously, our team have used gamma ray data and M-cube data together with Clementine data to see how we can use the imaging and gamma ray data to understand the surface lunar geology and resources mapping. So this will be continued. And the Korea has announced that we're gonna have lunar lander by 2032. The Korea is focused on launch vehicle capability, and then lander and the orbiter, and then all necessary astronaut training and the lunar base and mobility and deep space network and things like that. So this is very actively working on by the government, and then all national institutes are working together. For Korean National Institute for who focus on geology and mineral resources, especially payload development and then resource assessment, and then resource administration and resource extraction and utilization. So I'm waiting for 32 lunar lander participation, and we'll focus on resource extraction. There is a lot of activities are going on. Of course, the Korea signed for Artemis Accord as a 10th country. We are eager to do international collaboration. I think this is happening right now. So I hope this time I could have some connections with anyone who are interested in collaborating with Korea. So this is, yeah, funded by. Thank you so much.